Hello everyone. In the previous session, we learned about the ways of finding data characteristics, understanding data summaries, correlation and covariance of the variables to find how two numeric variables move together. Later, we learned how to pre-process the data to ensure quality and used various chart types to understand relationship between two or more variables. In today's session, we shall introduce you to the model building task. All this while, we only handle data in its raw form, transformed it, and so on. Now, we shall understand the real purpose of doing all these steps. So, what do we understand from the phrase model building? In statistics, we model the historical data in order to predict the future data. Since we look at the past and predict future, the term is named as regression. So during this modeling, what we are essentially doing is capturing the relationship between several variables in the data in order to predict the future behavior. So for instance, if we have to understand the sales pattern, that is the past sales pattern, and be able to predict the quantity of items to be manufactured. So in this case, we are studying the behavior of sales in the past, and we are going to predict based on the past behavior what is the quantity of items that have to be manufactured. That is one problem that can be solved using regression analysis. Another instance is understand the performance of students in the high school and predict their performance in graduation. So here, like we have taken this example in the previous sessions as well, we have collected the information of their scores, student scores in the high school, and we will predict their future performance based on the past performance. So that is how the term regression came in. Now let us understand the terminology. We have data and there are either independent variables or dependent variable. So in the data we always have only one dependent variable and several independent variables. So independent variables or explanatory variables or features or attributes or predictor variables. All these terms mean the same. And dependent variable, target variable or response variable mean the same. So these terms are interchangeably used in literature. So what we mean here is we want to study the influence of independent variables on the dependent variable. So in the example that we have just discussed, the performance of sales in the past, so that is the independent variable, and dependent variable is quantity of items that have to be manufactured. So quantity of items is dependent variable and the sales pattern is independent variable. So let us take a look at an example. So in this case, the box that is highlighted in blue, those are the variables that are called as independent variables or predictor variables or explanatory variables. Whereas the box, the rectangular area which is highlighted in red, is called as response variable or target attribute. So as you see in regression problem, what we are trying to predict is a numeric value. So in the previous case also, like we are predicting the quantity of items to be manufactured, and in the school performance of the students case, even there we are going to predict the performance in the graduation, which is again going to be a numeric variable. So here how do we understand is, we want to predict the future values. So given the, now suppose we get another cereal name where we have the calories, sugar, potassium, vitamins, shelf life, weight and cups. We want to understand what will be the rating. So based on the past past ratings as well as the nutritional aspects of each of the cereals, we can predict what will be the rating for the new cereal. Let us take a look at few more examples. Here what I want to explain is about two terms. One is linear regression analysis, the first one, where we have one independent variable that influences the dependent variable. So for example, the health insurance company might conduct a linear regression plotting number of claims per customer against the age, and discover that the older customers tend to make more health insurance claims. So here what we are studying is, from the past data, understand the influence of age on the number of claims. So here the age is independent variable, whereas the number of claims is dependent variable. That is what we will predict. The second example is the same, the students' performance based on the number of hours they study for exam. So here the independent variable is number of hours that they spend for the study, and the dependent variable, that is the target or the response variable, is their score or their performance. Another instance is to find the price of the product based on the past sales. So based on the sales of the products in the past, we need to predict the price of the product. So as you observed, in all these cases we had only one independent variable and dependent variable. So when we have only one independent variable that influences or impacts the dependent variable, we call this as simple linear regression analysis or linear regression analysis. On the other hand, when there are more than two or more than one independent variables that influence the response variable, then we call this as multiple linear regression analysis. So for instance, we have the data was collected on 1,000 houses recently sold in the city. It consisted of sales price, the house size, the number of bedrooms, number of bathrooms, the lot size, and the annual real estate tax. So here, as you see, there are several independent variables. Now the second case is the cereals data that we just discussed. There are several health or nutritional aspects about each cereal, and the rating is provided. So based on the amount or the measure of per serving for each of the cereals, we need to predict the rating. So as you note, the number of attributes, that is number of independent variables, are more than 2, and hence we call this as multiple linear regression analysis. And the last example, the third example, is about finding the prices of export industries so that the local planners in there can use the underlying economic characteristics of the model industries in decision making. So they collect several economic characteristics in order to predict the price of export. Now let us understand how the regression model is built. So first step in the regression is to find the relationship between independent variable and dependent variable. And how we do that is we could use a visual representation such as scatter plots, and we know how to quantitatively understand the strength of the relationship, that is using correlation coefficient. If you recollect, the correlation coefficient, the values range between -1 to 1, and if the value is positive and closer to 1, we understand that the strength of the correlation is high, and the way we understand is both the variables move together. Similarly, if the correlation is negative, what we understand is the variables are more or less moving in opposite direction. And if the value is closer to -1, we say that they are strongly negatively related. Now, what if the correlation between the variables is very high? What it means is that we could use either of those variables and drop one. So why it is important is we just want to avoid the impact of such variables on the dependent variable. If there are correlated variables within the data or correlated independent variables, there is a chance that it will impact more, or it will show up a lot of influence on the dependent variable, and there is a chance that the predictions might not be reliable. So here we have example of two cases where we have plotted the scatter chart for weight versus height and advertising dollars, that is the expenses versus the sales. And if you note, as the dollar price is increasing, the sales also is increasing, so we expect a positive correlation between them. Let us review a little math before we get into the regression fit or regression analysis further. So if you recollect from your sessions in the beginning where we covered how we can understand the data, if there are, say, two attributes, age and income, so say x1 and y1 and x2 and y2 for two different customers. So in a two-dimensional plane we have these 2 points. So if you see here, we said x1 y1 and x2 y2. So x1 y1, or we can take an example like x is the expenses and y is the sales, and we can always draw a line or construct or create a line between 2 points. Now once we create the straight line between 2 points, we have the two characteristics that can define the straight line. One is from where or what point the line is going to cut or divide the y-axis, that is this part. Okay, So this particular line is cutting the y-axis at this point. So what point is the straight line cutting the y-axis, and how is the trend of the line? So is it a positive trend or a negative trend? So the positive or the negative trend can be computed using the slope. So if you note here, we have the straight line equation, which is represented as y equal to mx plus b, where b is the point on y-axis where the line crosses, and m is the slope, which tells us the direction or the trend of the straight line. Now, why it is important to understand the straight line and the slope and the intercept is, in regression analysis, when we have the scatter plot, or when we for two-dimensional or three-dimensional, it is pretty easy to view how the scatter is and how the line fit is. But once it gets into more than 3 dimensions, it becomes difficult. So just trying to explain how the straight line fit works in regression analysis. So the regression line or the fit is the line that is closer to the points or to the scatter. So as you see, there can be multiple possibilities or multiple ways of drawing the same straight line. So we have a red line, blue line, and a gray line. So all these three are possible to fit the data. However, what is important here, it's not just fitting a straight line across these points. What is important is the line that actually has least error. So let me explain this to you. We find a straight line and we know the points on the straight line. We have the actual points that are scattered around the straight line. We take the distance from each of those points on the regression line. So as you see here, we have the points and we take the distance from the line. And overall, once we compute the difference between the actual and the line fit, we try to minimize that. So although we have multiple equations or multiple lines that are possible that fit the scatter plot, but we choose the line where the error is minimum. So that is all what the regression analysis does. It tries to build this fit or the linear or a line that has the least error. So a regression line will always contain error terms, because in reality independent variables are never perfect predictions of the dependent variable, and the regression line is the line with smallest possible set of distances between itself and each data point. So as you can see, some of the points are not touched by the regression line, whereas some are very close. So in some cases we tend to make more error, in some cases there is a small error. So the distances of all the data points from the regression line is termed as error. So let me just explain this again. Y equal to a plus bx is the regression fit. So y hat, which is called as the predicted value of y, which is the regression line, this one is y hat. It's represented as y hat, which is also termed as the predicted value of the y, which is the response variable. So this are the points on the regression fit, and how we compute the error is, from each of the points around the scatter we compute the actual point minus the regression line point on the regression fit and compute the error. So here in this case, if you see, y2 is a point, y2 hat is a point on the regression fit, and we take the difference between these two, and this is nothing but the error. So at this point, let me explain you the assumptions of linear regression analysis. So the assumptions or the basis on which the linear model tries to find the best fit is that the variables, that is the independent variables, are identically distributed, and the error that we have found is also identically distributed following normal distribution with mean equal to 0 and standard deviation equal to sigma square. So what we understand from this is, first thing, the variables have to be independently normally distributed, and the errors will have to follow normal distribution with 0 mean. That means all the errors should be closer to 0. That is, the average value of the errors should be around 0, and the variance of these errors should be same. Only then this particular analysis will hold good. So based on these assumptions and how best so based on these assumptions only we can find out the best fit of the data. So here where we say the advertising dollars and about the sales, we have the straight line fit, and we have the data up to certain duration, so say up to $7,000, and after that, after which the line is extended to tell us the future predictions. So let me explain you this. What we are trying to do here, we are trying to get the best fit. When we say best fit, what we mean is the line that makes least error. So in mathematical terms, what we are actually trying to do is trying to minimize the errors, that is minimize yi minus yi hat. We have seen yi hat is nothing but the points on the regression fit, and that is what we are trying to minimize. So this concept is called as the least squares method, and this particular method is used to find the best fit. So the least square methods is based upon the principle that sum of the squared errors should be made as small as possible, so the regression line has the least error. So what we mean here, sum of the error squares. We know that yi minus yi hat is error, and we are saying that the sigma notation here stands for sum, and we are trying to minimize this sum. Once the line is determined, it can be extended beyond the historical data to predict the future values. Now let us try to understand this in generic terms when we have several or more than two or more number of variables in the data. So even when we have two or more variables in the data, we still have to understand the relationship between the predictor variable and the response variable. So as you see here, we have actually three variables, x1, x2, x3, and we see the three-dimensional plot saying y1 x1 x3 and y1 x1 x2. So we are trying to find out the scatter, and this same extension can be visualized in the form here. So as I mentioned, the straight line fit will become a plane, and we compute the distance between each of the points in the scatter and the point on the plane, and we try to find the best fit. So in the case where we had only one independent variable, we said the equation is y equal to mx plus c, where x is only one independent variable. Whereas in this case, when we have several variables, independent variables, the form of the straight line or the equation is y equal to beta naught plus beta 1 x1 plus beta 2 x2 beta n xn plus error. And here, if you note, y is the response variable or dependent variable, betas are the coefficients, and x1 x2 xn are the predictor variables or the explanatory variables, and e is the error, which is the residual or the random error. So the equation, in this equation, what does the coefficient stand or mean is, the coefficients here, or the way it is quantified, it tells us the magnitude or the proportion of impact that the particular variable has on the dependent variable. If beta naught is say 5, beta 1 is say 10, beta 2 is say 3, and beta n is say 2, then the way we understand is x1 has much more impact on y than the other variables. So as we have discussed, if we are able to fit a linear line between the points, we call that as a linear regression. However, there can be a form where the linear or the straight line fit is not apt. In those situations, the fit can be a non-linear fit, where the line can be a curve, a polynomial, or a quadratic equation. So regression models can be either linear or non-linear. A linear model assumes the relationship between variables are on a straight line relationship, while a non-linear model assumes the relationship between the variables is represented by curved lines, or it can be a quadratic or polynomial equation. Here, the important thing that we have to understand is the coefficients that we have, the betas, are still linear. They are not square terms or cubic terms. So although the x1 x2 take the non-linear form, this method is called as linear regression because the coefficients are linear in nature. Now let us take a look at a simple example where from the serials data I have just taken two attributes, that is one independent variable and one dependent variable. So calories per serving is given for each of the cereals and the corresponding rating is given to us. When we plot this, we see that there is a negative relationship between the calories and rating. So if you see here, as the number of calories are increasing, the rating is coming down. So the equation that you can expect will be a straight line where the trend is downwards, like this. So if you see, we have a straight line, but then the trend is downwards, and that is the reason why we see the coefficient of x, that is calories, has a negative relationship with the rating, which is y. So here y is the rating and x is the calories per serving, and we see there is a negative relationship between x and y. The R square we will cover in the next session, where I will explain how to understand R square. At this point, just understand that the relationship between two variables, that is dependent and independent, can be understood from a scatter plot and the line fit. Here in this case we see there is a negative correlation between the calories per serving and rating. So as the calories increase, the rating is going down. At this point, let me break, and in the next part of the same video we will look into the example and work out in R deducer.